Example 1e. Subtract the rational expressions 5x plus 1 over 4x squared minus 9 minus 2x over 2x squared minus 5x minus 12. Our first step is to determine the least common denominator. And in order to do that, we want to factor both of these denominators. So let me begin by writing our first denominator, 4x squared minus 9, and I want to factor that. Notice this is a difference of squares, and 4x squared minus 9 factors as 2x minus 3 times 2x plus 3. Let's take a look at our other denominator, 2x squared minus 5x minus 12. Again, we want to factor this. Two x squared minus 5x minus 12 factors as 2x plus 3 times x minus 4. So we've now factored both of our denominators. Our LCD consists of the following. One factor of 2x minus 3, one factor of 2x plus 3, which actually appears in both of our denominators, and one factor of x minus 4. So our least common denominator is 2x minus 3 times 2x plus 3 times x minus 4. We now convert our rational expressions to have this new denominator. I rewrite them, so I have 5x plus 1 on top, and on the bottom I'm going to factor this out as 2x minus 3 times 2x plus 3. We're subtracting from that. Over here, 2x, and 2x is over top of this polynomial, which factors as 2x plus 3 times x minus 4. And we're changing these two rational expressions to each have a new denominator, and that new denominator is our LCD. 2x minus 3 times 2x plus 3 times x minus 4. And that's in both of these denominators, 2x minus 3 times 2x plus 3 times x minus 4. So we go about asking ourselves, what is it that we have to multiply by these denominators to achieve our least common denominator? Well, in the first example, we have 2x minus 3 times 2x plus 3. So the factor that's missing is simply x minus 4 in this first rational expression. And if we multiply the bottom by x minus 4, we also want to multiply the top by x minus 4. And so that gives me, in the numerator, 5x squared, I'm going to multiply it out, 5x squared plus 1x minus 20x gives us minus 19x's, right? Plus 1x minus 20 is minus 19x's, and then minus 4. That's our new numerator. Now let's take a look at the second rational expression. What is it that we need to multiply by? We have a 2x plus 3 and an x minus 4. What's missing is the factor of 2x minus 3. So we need to multiply both the denominator and the numerator by 2x minus 3. And when I do that, what do I have on top? I have 4x squared minus 6x. Perfect. We have like rational expressions now because there's a common denominator. So we're going to combine the numerators and put our answer over that common denominator. 2x minus 3 times 2x plus 3 times x minus 4. When we combine them, we want to be very careful. This is a subtraction in between. So when we subtract, remember, you want to subtract every term in the numerator in the second fraction. So be very careful. Here we go. On top, we have 5x squared minus 19x minus 4, and then minus 4x squared plus 6x, right? Minus 4x squared plus 6x. Let's continue by combining like terms. So what does that give us on the top? That gives us 5x squared minus 4x squared. So that's going to give us an x squared on the top. Minus 19x plus 6x gives us minus 13 or negative 13x. And then minus 4 is just minus 4. All of that is over our denominator, 2x minus 3 times 2x plus 3 times x minus 4. Is there anything that cancels? Well, in order to cancel, we'd have to factor out the top. And you know what? X squared minus 13x minus 4, this doesn't factor. So there's nothing that can be canceled from numerator and denominator, and that means that's our final answer. Our final answer is x squared minus 13x minus 4 all over 2x minus 3 times 2x plus 3 times x plus 4. 5 over m squared minus 4m plus 4 minus m over m squared plus m minus 6. Observe we have subtraction this time, and in order to subtract two rational expressions, we need a like denominator. These are different, so our first step will be to obtain the least common denominator for these rational expressions. How do we do that? Well, we have to factor out each denominator first. So let's start here with m squared minus 4m, m squared minus 4m plus 4, and let's factor this out. Notice this is a trinomial. It factors as the following: m minus 2 times m minus 2. Check it. M squared minus 2m is minus 4m. Negative 2 times negative 2 is positive 4. So m squared minus 4m plus 4 factors it as m minus 2 times m minus 2. Let's take the second denominator. M squared plus m minus 6. This is also a trinomial, and it factors as follows: m plus 3 times m minus 2. Again, check. M times m give us m squared. 3 times negative 2 gives us negative 6. Plus 3m minus 2m gives us plus 1m. Wonderful. We factored out both of these denominators. Now we have to determine the LCD. The LCD has to contain two factors of m minus 2 to account for both of them in the first denominator, m minus 2 times m minus 2. And it also has to include one factor of m plus 3. So our least common denominator is m minus 2 times m minus 2 times m plus 3. Let's go back to our problem. Let's rewrite it first. 5 over, and let me write this out in factored form, m minus 2 times m minus 2 minus, and over here I have m over, and again write this out in factored form, m plus 3 times m minus 2. And what's this equal to? Well, we need to make it equal to two fractions that are the same, and those fractions both need to have the least common denominator of m minus 2 times m minus 2 times m plus 3. M minus 2 times m minus 2 times m plus 3. So our job is to determine what we need to multiply by to change this fraction into a new fraction with this denominator. Notice I have m minus 2 times m minus 2. I'm missing the factor of m plus 3 from this first rational expression. So I need to multiply it by the numerator and the denominator. And that means my new numerator is simply 5m plus 15. 5 times m plus 5 times 3. Take a look at the second fraction. I have an m plus 3 and an m minus 2. What's missing is this extra factor of m minus 2. So I need to multiply both the denominator and the numerator by m minus 2. Doing so, my new numerator becomes m squared minus 2m. So far, so good. We now have like rational expressions which we can subtract. When we subtract, we'll combine the numerators and it will be put over the least common denominator, m minus 2 times m minus 2 times m plus 3. Let's proceed. On the top, we have 5m plus 15. Now, remember, this is a minus sign, and this minus sign must apply to every term in the fraction that comes after. So minus m squared minus minus. All right, so as we go through, our numerator now is 5m plus 15, and then minus m squared minus minus, which makes it plus 2m. Good. We now combine our numerator, and so as we combine, let me put it over here, we get negative m squared plus, let's combine like terms here. So I have a negative m squared, and then I have a 5m and 2m, so that's going to give me plus 7m, and then plus 15. All over, let's see what we've got on the bottom, m minus 2 times m minus 2 times m plus 3. Can we reduce? Can we do anything to reduce? Well, we have to factor out the top first to see if that's possible. So let's take out a negative 1 from the lead term, and that gives us m squared minus 7m minus 15, right? M squared minus 7m minus 15. And the bottom is simply m minus 2 times m minus 2 times m plus 3. Can this factor? Two factors, two numbers that multiply to negative 15, add to negative 7. This doesn't factor, does it? It's factored as far as it can go. Therefore, there's nothing that we can cancel. So we can stop here. This answer is reduced as far as possible, or we can stop here. Either answer is the difference of these two rational expressions. That ends example 1D.